don't know if the people will, okay. So Arash, can you get set up? And I just want to mention that if you have more questions, please put them in the Slack channel and then the speakers can get to them. And we also have a discussion session in the afternoon. So our next speaker is Arash Bahramian, and he's going to be speaking a bit about GRS1915. We heard something about the dimming yesterday. He's going to continue. Go ahead.
All right, can you hear me?
Yes,
just
we hear
making
you.
sure that, all right, great. Thank you very much. I do apologize if I cut off occasionally. It might be my internet. It's not great, but without further ado, thank you very much for the opportunity. Yeah, I'm going to talk about GRS1915, I presume your own in the talk, in one of the talks yesterday, at least mentioned this during the time where I was asleep, as it was midnight Australia. So just a quick background on the system. So GRS1915 has been, is a bright black hole low mass X-ray binary with a roughly 10 solar mass black hole and a around 0.4 solar mass K or M giant companion in a 34-day orbit. And it's been bright in the X-rays since the discovery in 1992, and it has shown superluminal ejecta, and it is one of the archetypal galactic microquasars. So because of its bright nature and long history, it has been studied in detail over the past decades in the X-rays. So what you see here, the top panel is the X-ray from various detectors. And in the radio and in the infrared, there are correlated variability across the electromagnetic spectrum. And it has very high extinction in front of it, so it is better observed in the infrared bands, which it has been observed. With that in mind, it is also known that it shows a lot of different variability profiles. These variability states have been studied in detail over the past decades. And so what I've shown here for consistency, this is MAXI, BAT, and their relative hardness ratio in a normalized manner, so that a negative value would be very soft and a positive value would be very hard. And so until 2015, this thing showed jumping up and down around. And then between 2017 and around 2018 showed these interesting dips in the X-rays. And then this was followed by the dimming that we saw that has been studied in detail. And I'm going to get to that a bit more. Since 2018, it jumped down, especially in the soft X-rays, and has got fainter and fainter. So I'm going to focus on this trend a bit more. So on the surface, when we look at this profile, it kind of looks like this whole decline kind of fits the profiles that Guillaume talked about, for example. That you kind of see an exponential decline and a linear decline at the end. And so it kind of appears it is going to follows the disk instability model towards quiescence. However, multi-wavelength observations during the state, during this evolution showed that it's a bit more complex. So from what we can say is that, for example, this part, for example, is similar to a very hard state. This was observed in the radio and the X-ray and by various people, and Kari Koljonen and others have documented it. Then there was a slightly rebrightening, which is actually more pronounced in the soft X-rays, that it goes a bit up before jumping down. So before getting to the hard state, we can assume this is the soft to hard transition, and then it gets to a hard state, it stays there, then it rebrightens, and then jumps down, which is the focus of what I'm going to talk about. And hence why I included a bit more information about it. So this this drop down and the consequent state was noted in the X-rays, and it was accompanied by X-ray flares, radio flares, and brightening in the infrared. There were absorption lines earlier seen around this point that then later on around here were observed to be an emission. So all of these pointed to the speculations that, well, this is not consistent with going towards a very intrinsically X-ray faint state, but it is probably actually X-ray bright state, but it is very obscure, especially radio flares, X-ray flares, and the spectral lines. This was speculated and have been discussed by Mata et al., Nielsen et al., and Miller et al. But one thing that we were wondering about was, can we actually look at the accretion disk a bit more directly and see how it has evolved in this sense, given that the X-rays are obscured? And for that purpose, we selected, decided to go after it with X-shooter. So this allows us to study across the 3 JHK bands in infrared. And although it might be a bit overkill because GRS1915 is relatively bright in the infrared, near infrared, it allows us to actually directly compare with archival data that were taken in the past with the same telescope. So the vertical lines you see between 2009 and 2011, these vertical lines are all X-shooter spectra that were taken of GRS1915. So it covers nicely the scale of variability of the source in pre-2018 decline. And the vertical lines you see here are our observations that were taken as the source got fainter. So this gave us a very nice baseline to compare. So starting to probe that, so what you see here is the H-band and K-band spectra of the GRS1915. The colored spectra are from 2019, and the gray spectra represent the archival data from 2010. So the very first thing that is very clear is that the near-infrared continuum has got brighter, which is not surprising. This was also indicated in photometry of the system. However, the more exciting thing to go after would be the emission lines. For example, the bracket gamma that is here and is linked with accretion. So zooming in on that bracket gamma feature in the flux calibrated data, the amplitude seems a bit higher than compared to the archival, and it's not always symmetric. So this is, for example, on this data, which was taken on June 25th, it seems rather asymmetric, which may be indicative of presence of disk width. Now, when we normalize the spectra together, it also appears that they are way broader, and more than that, they are substantially broader compared to the archival data. And in addition, we notice that there is this helium-2 line that is around here. This is important because this helium-2 line typically only is observed in the brightest accretion states of Z sources, for example.
Arash, you have 3 minutes. 3 minutes.
Thank you very much. So that's also interesting to see this, especially in an X-ray, apparently X-ray faint state, obscured state. So we compare the bracket gamma full width half max with the mean flux density of the continuum, and we see that the trend kind of continues that we would expect when things get brighter, go into an X-ray brighter state. So from the archival data, so the black circles are archival, and these are the new data. This is typically seen in brighter states. However, more important is to put these in the context of the X-ray luminosity, X-ray brightness, at least as we see, and that becomes a bit more interesting. So what you see on this side, this is the bracket gamma line full width half max versus the maxi flux as observed. And as we see, well, yeah, bracket gamma gets brighter as the maxi flux goes down. This, while this is a bit odd compared to many other sources. And more importantly, when we look at the continuum brightness in the infrared compared to the maxi flux, we see that the trend that we expect at high luminosity states, which is that the near infrared continuum goes up with the X-ray flux, is held. However, it seems to have shifted completely down by something like an obscuration. So with that in mind, what we have seen is that, as others have suggested, the system is in an intrinsically X-ray bright state. However, now infrared clearly shows that this not is only an X-ray bright state, this might be the brightest state, X-ray brightest in the X-ray that the source has ever been. And with that, I conclude and have to answer any questions. Thank you.
Thank you very much, Arash, and thank you for keeping the time. Let's see, do we have any questions now for Arash? I'm looking on the Slack and, oh, I see Federico, go ahead.
Hi, Arash. Thank you very much for the talk. Very nice. Is the source showing some kind of variability within the observation? Can you
within the observation, we have been probing it in finer timescales between the exposures. We don't still have conclusive results. We think there is a little bit of variation, but it's not strong.
Okay, thank you.
Before we have one in the room.
Yeah.
Okay, let's go. So, oh, sorry, oh yeah, okay, great.
Yeah, hi Arash, this is Marianne. Very nice results, really. This reminds me of some of these ULXs, like P13, for example. There's something similar where it's now dimming in X-rays by a lot, but the optical and the optical radiation and also the spin up of the neutron star indicate that there's still accretion going on. So could they be similar?
Absolutely.
Like in that case, I think it seems to be some sort of precession, perhaps, that's like beaming most of the X-rays out of our.
I'm not an expert on ULXs, but I wanted to actually mention that, but I thought maybe it would be a bit more hyperbolic. So but yes, I agree with that.
Okay, thanks.
All right, we have time for one quick question. I think Maria had her hand up first. So Maria.
Yes, hi, very nice talk, thank you. If I remember correctly, I mean, there were in the 90s some claims of bracket gamma lights pumped by radio flares. So I was wondering whether you have checked also the relation of these lines with radio emission.
No, I haven't. That's a very good point. No, I haven't. I should look into that. Thank you very much. No, I haven't.
You're welcome.
I think there's some other questions already in the Slack. So Arash, you can start to look at those and let's move on. Thanks again to Arash, and our next speaker